This is the composite design pattern by Anthony Vitrino, CIS476, Winter 2023. Composite pattern intent. The composite design pattern is structural. It lets you compose objects into tree-like structures to represent part-whole hierarchies. A system consists of subsystems, or components. These components can be further divided into smaller components, and those can be divided into smaller elements. This lets clients use these structures as if they were individual objects. Essentially, it allows you to have a tree structure and ask a specific node in the structure to perform some task. Composite motivation. We as computer programmers often must recognize a distinction between branches and leaf nodes when dealing with data structure in a tree. This can make our code more complicated and prone to errors. A nice solution is to work with these components and subcomponents through a common interface that allows treating these individual and composite components uniformly. It's used to build part-whole hierarchies, construct data representations of trees, and when you want your clients to ignore the differences between individual objects and compositions of objects. Real-world problem and solution. Amazon often deals with the shipments of large orders that contain multiple products in each order. Often an order is received by the consumer, and this order has one big box, with the possibility of that box containing other small boxes with products. Or that big box could contain individual products, or a combination. How would a program calculate the price for all the products in this order? In a computer program, it's not as simple as looping through to calculate each individual product's price and returning it. A solution would be to have a common interface which declares a method for calculating the total price. For a box containing products, it would ask each product for its price and then return a total for this box. For individual products, they would just simply return their price. Real-world analogy. As we can see, the Office of the Secretary of Defense is structured as hierarchies. It is broken down into different divisions, and those divisions are broken down into smaller divisions and roles. Orders are given at the top by the Secretary of Defense and passed down onto each level until everybody knows the task they need to perform. Composite structure. Here we have the client. The client works with all elements through the component interface. The client can work in the same way with both simple and complex elements of the tree. Here we have our component, which is the interface, and it establishes operations that are common to both simple and complex elements of the tree. Here we have our leaf node. The leaf does not have any sub-elements. The leaf defines the behavior for the elements in the composition. It implements the operations the composite supports. Here we have our composite. The composite is an element that has sub-elements, leaves or other composites. A composite doesn't know the concrete classes of its children. It works with all sub-elements only through the component interface. When it receives a request, a composite delegates the work to its sub-elements, processes intermediate results, and then returns the final result to the client. So the composite delegates work to the children. That could be another composite, which also has here the common operation is this execute. So the composite can delegate to other composites. They can perform their execute, or can delegate it to leaf nodes, which also share this execute operation, and they perform some other work too. Composite participants, the client, which manipulates objects in the composition through the composite interface. That should be component. Component implements default behavior, declares an interface for accessing and managing the children components, and declares the interface for the object composition. The composite stores the child components, implements child-related operations to the component interface, and defines behavior for components having children. The leaf, which usually does most of the work since they don't have anyone to delegate the work to. Composite pattern consequences. This pattern provides you with two basic element types, leaf nodes and composite nodes. The composite can be composed of both leaves and other composites. This lets you construct a nested recursive object structure that resembles a tree. All elements of the composite pattern share a common interface that shields the client from worrying about the concrete class of the objects it works with. The component interface establishes operations for the leaves and composites. The composite receives requests and delegates work to its sub-elements or leaves and returns the final result. The leaves do the work. When to use the composite pattern? When you have to implement a tree-like object structure and define class hierarchies. When you want the client code to uniformly treat simple and complex elements. When the client isn't supposed to know or care about dealing with leaf or composite elements. This is the demo for the composite design pattern. We'll start with our common interface, which is a squad member, we're calling it. This describes operations that are common to both simple and complex elements of the tree. Simple, which is a leaf, that is going to be our soldier and our medic. Complex, or composite, that will be our leader. And both of these simple and complex elements share this operation, show details. Now for our leaf nodes, soldier and medic, it implements squad member, the common interface. It has its constructor and its own implementation of the show details. Here we have our leader, which is our composite. It contains a list of sub-elements or their squad members that are under their leadership. Essentially here, just I guess think of it as like a hierarchy for some sort of military division. So this composite element also implements the common interface. It contains the list of its children, each squad member or member under their leadership. It has its own implementation of the show details operation. We can also add and remove different child elements. Here we have our client, basically. In here we're creating a few leaf elements, 2 soldiers and a medic. We're creating a composite, calling it Squad 1, and the position just being Squad 1 leader. So this Squad 1 leader, we're adding each member, each medic or soldier to this Squad 1 composite. So essentially this Squad 1 leader contains, has these 3 leaf nodes or soldiers and medics under its leadership, basically. Here we're doing the same thing, pretty much the same thing, just calling it something different. Squad 2, few soldiers and medics, adding them. So now we have essentially 2 different tree structures, composite containing 3 leaf nodes, another composite containing 3 leaf nodes. And we're just simply asking this composite to show details. It receives that request. It delegates work to its children to perform their own implementation of the show details. That can be shown right here. Doing the same thing for this. So now 2 different tree structures, 2 composites that contain 3 child elements each. And here we're creating another hierarchy to our leadership and calling it general. So this is another composite. We're adding 2 of our previously created composites to this composite as children. we're asking this new hierarchy general to show details, its own implementation. That being for composites. This delegates to each other composite to show details. Each one of these composites will delegate to its children to show their details. So now we have one big composite, or one composite on the top of the hierarchy, the general. It has Squad 1 leader and Squad 2 leader under its leadership. And each Squad 1 and Squad 2 leader have the 3 children under their leadership, soldiers and medics. So overall, a composite that contains 2 composites of children. Those 2 composites each contain 3 smaller sub-elements, being the leaf nodes. And we'll run it. This is the first output, first tree, second tree, and both of them combined under this general composite, which has Squad 1 and Squad 2 leader under their composite. As you can see, it's delegating the show details function to each of its children. The general delegates to the Squad 1 leader and the Squad 2 leader, show details. Squad 1 leader, Squad 2 leader delegates to its children, the soldiers and the medics, to show their details.